Let's begin Section 2.1, which is on pages 102 through 109 in your textbook. For practice, we'll complete Exploration 2.1 Part A for class. So far, we've covered steps 1 through 3 of a statistical investigation. We're going to skip step 4 for right now and discuss half of step 5, generalization. How broadly do the results apply? In Section 2.1, we'll specifically be talking about sampling from a finite population. There's a lot of new terminology in this section in the textbook, so make sure you have read it carefully, highlighted it, and taken good notes. A statistic is a numerical summary of a variable collected on a sample. A sample is a group of observational units data is actually collected from. A parameter is a numerical summary of a variable for an entire population. And a population is the group of all observational units of interest. As an example, let's say I'm interested in all MSU students. Then the population would be all students at MSU. If I wanted to know about the variable height, then my parameter would be the average height of all students at MSU. If I took a collection of 50 students and recorded the heights of each of those 50 students, those 50 students would be my sample, and the average of those 50 heights would be my statistic. A sample, hopefully, is representative of your population. A statistic is an estimate of your parameter. Statistics is a language that comes with not only its own terminology, but also its own symbols. Here, we look at some notation for different statistics and parameters depending on the type of variable recorded. If a variable is categorical, we would use p hat to represent the proportion in the sample, and pi to represent the proportion in the population. For example, if I were recording about all MSU students, whether or not they own a dog, then pi would represent the proportion of all MSU students that own a dog, and p hat would represent the proportion of MSU students in my sample who own a dog. If my variable is quantitative, like we talked about height on the previous slide, x bar would represent the height of 50 students in a sample, and mu would represent the height of all students at MSU. When we're talking about quantitative variables, we should also talk about the variability, which typically is measured using standard deviation. Sample standard deviation uses S as its notation. The population standard deviation would use sigma. Note we always use Greek letters for parameters because parameters are unknown numbers and we don't know Greek. Notation for statistics come from our Roman alphabet because statistics can be calculated from our sample data. Here's some more new terminology. A census is a study which collects information from an entire population. A census is difficult, time-consuming, expensive, and therefore very rarely done. A sampling frame is a list of all observational units in the population. For example, a list of all MSU students, if MSU students are my population, or a list of all NCAA institutions, if NCAA universities is my population. A simple random sample, sometimes abbreviated SRS, is a sample which ensures every sample of the same size is equally likely to be chosen. Or in other words, every observational unit in the population is equally likely to be included in the sample. You could take a simple random sample by taking your sampling frame, putting every observational unit's name on the same size slip of paper, and drawing them from a hat. Or you could use a random number generator to choose a sample from the sampling frame. Is how much one sample statistic would differ from another. In other words, if I took a sample of 50 MSU students and found the average height in the sample, and then took a different sample of 50 MSU students and found the average height in that sample, how much would those two averages vary? Sampling variability is a very big idea in this course, and we would measure it using the standard deviation of the statistics from many different samples. A sampling method is said to be unbiased if it produces samples which are representative or similar to the population on the variable or variables that are measured. or when the statistic from samples collected using a sampling method vary around the parameter. There are lots of ways a sampling method could be biased, in how the sample was collected, how the questions are asked, or how and whether the person responds. View the bias video for more information on forms of bias. Generalization is the ability to extend the results from a sample to the population from which the sample was drawn. Generalization can only happen if the sample is representative of the population or when the sampling method is unbiased. Finally, convenience samples are a sampling method where you collect data from people who are easily accessible. For example, surveying coworkers, asking Psych 101 students to participate in research, or standing outside the athletics building to talk to athletes.